point Q represented by x2, y2. So now we have to find out distance between these 2 points or line segment, or this is called line segment. Now we have to draw the perpendicular line. This is the perpendicular line, so which is perpendicular to x-axis, and similarly draw the another one line that is perpendicular to y-axis. Okay, so x1 is the value represented on the x-axis, so this is x1. So this is the origin, this is M. The distance between OM is x1. Okay, the distance of the point M from the origin O is x1. Similarly, the distance, this is the S, so this is PS. The distance between these 2 points or PS is x1 because these 2 lines are parallel or equal. So if you find out the distance between PM, so this is the value y1. So y1 is the y coordinate, or this is the value represented on the y axis. So this PM is, or this distance we can take it as OS. This distance is y1. So OS and PM are both equal. So this value is also y1. Similarly, if you draw the perpendicular line Q to the x-axis, this value is x2 and this distance is also x2. Okay, and this distance, see here, similarly draw the perpendicular line, and this distance is also x2 because these 2 lines are parallel or equal. So now we have to write the distance, this distance, that is q, and represented as this is n. This is q1, this is y1. So here this value is y1. Y2. This is y2. So y2 is the value represented on y-axis. So this value is y2 and this total value is y2. Okay. Now draw the another perpendicular line. This is, we can write it, another one perpendicular line on this q1. This is represented by PQR. See this line. So angle. This is P, this is Q, this is R. So P is x1, y1 and Q is x2, y2. Okay. See here. So here, see here, this is PR. Okay. So here the OM is x1, OA is x2. So this value becomes x2 minus x1. So we have to subtract the x1 from x2. We get the length of MN. Similarly, see here, this point can be represented as or D. This OD is y2 and OS is y1. So this distance is SDS. So this distance becomes y2 minus y1. Okay. So see here, this distance or this line equal to this line. So QR becomes y2 minus y1. And similarly, see here, this distance, this MN is equal to PR because these 2 lines are equal. So that it becomes x2 minus x1. So now we have to find out distance between these 2 points. This is the right angle triangle. So we apply the Pythagoras theorem. The Pythagoras theorem is, so Pythagoras theorem is, this is the hypotenuse. So this hypotenuse square is equal to, so here PQ is the hypotenuse. The PQ square is equal to sum of the other 2 sides. Sum of the square of the other 2 sides. So that here other 2 sides are PR. So PR square plus another side is QR. That is QR square. So see here, the PR is x2 minus x1. So see here the value PR is x2 minus x1 whole square plus QR is y2 minus y1 whole square. So here PQ square. So shift the square to the right hand side. The square becomes square root. So this is square root of x2 minus x1 whole square, y2 minus y1 whole square. So this is the distance formula. You should remember that this is called the distance formula, which is used to find out the distance between two points lie on the coordinate axis.